So this is a kit we have made for which is a counter system. So whenever we need to count the number of people entering a room, we need to register it. So for that we can use this kit. So we have, as you can see, we have an entry point here. So from here, if a person enters, and then from here if he exits, so we have a system where the microcontroller detects the particular person and then increases the count here. And also we have another energy saving system in which if there are people in a room and if there is no sufficient light, then we have a system where the bulb will glow automatically, and if there is no person in the room, there won't be any bulb which glows automatically. So I'll just show you a demo. So now if we consider someone entering, the gate is opened, and now if he leaves, you can see the counter number has increased. I'll show you again. If the person enters from here and exits from this point, then it means the person has entered, so the counter number will increase. And this works in the opposite direction also. So as you can see, the counter number has decreased. So this is how the counting takes place. And as you can see, there is one person in the room right now. So if we cover this particular LDR, that is light detector resistor, as you can see, the light goes on automatically. So it means there's a person in the room but there's no light, so the light glows automatically. So this is how the energy saving kit works. So you can order this kit from our site kitscrew.com, where you'll get two versions of the kit. One is where you'll get this complete ready-made kit which you can see here, and the other one is where you'll get a complete self-assembly kit where you'll get all the components separately. And with the help of our video tutorials, you'll be able to assemble them and complete it by yourself. So in this section of the video, we'll see what all components are used in this kit and what are the functions of those components, how this kit works, and then how do we check the power supply. So before starting on to assembling the kits, we'll just discuss how this entire kit works. So first we have two PCBs here. One is the main PCB, which is the microcontroller PCB, and the other one is the motor driver circuit. So starting off with the power supply. So this is the power jack through which we have given the power through an adapter. This is a power supply given to the transmitter here. These two are the transmitters, IR transmitters. This is the on-off switch, which controls the entire power to the unit. This is a bridge rectifier. In case you are giving a power supply through a transformer, you can use a bridge rectifier, which converts the AC input into a DC output, and a capacitor which removes the repulsors which are produced during the rectification process. Then another parallel power supply given to the motor driver circuit. So this is a 12 volt supply. So the 12 volt supply will be given here. And then a voltage regulator IC, because most of the components in this PCB works on 5 volts. So we need to convert the input power supply to 5 volts output supply. And then this is the power unit for the LDR. As you can see, this is the LDR power unit, and these two are the power units to the receivers. This is for the transmitter, and these two are for the receivers. We'll later discuss how to connect in terms of polarity. Then this is an LM324 decoder IC, which decodes the signal coming from the IR transmitters. And then this is the main 40-pin microcontroller, and through which there are various functions taking place. So one is when this particular receiver or this particular unit detects any cut in the voltage supply or in the transmission supply, so it gives a signal to the microcontroller, which runs the motor, which opens the gate. And then when this particular unit detects a variation, it sends a signal to the microcontroller, which increases the counter value here. And if there is a dip in the overall brightness, or if the intensity of light is not proper, then you can use this. Then the LDR detects the signal here and sends it to the microcontroller in order to glow the bulb. So there are three functions, and the other one is the fourth function is to open to run the motor here. And this is the motor driver circuit. So the power unit is given parallelly from the main PCB, and this is 7812 IC, voltage regulator IC, which gives a 12 volt power supply to this entire unit. Now this is L293D motor driver IC, which can run two motors parallelly. So one terminal has been connected to a motor, the other one has been connected to a bulb, as you can see. So this is how the kit works. So now we'll see how to assemble those components. So this is a PCB, this is the top part, and this is the bottom part where the copper layers are present. The technology that we use is called a through hole technology, in which we drill holes from the top throughout the PCB and solder the components at the bottom. So for reference, I'll keep this PCB in line with the ready-made PCB to have a reference of the alignment and direction of each and every component. Starting off with the power jack. This is a power jack, and then a 2-pin connector. So a 2-pin connector here is used to give a power supply to the transmitters, as you can see. Here the positive, the transmitter is like an LED. So the stem which is longer in length is the positive terminal, in case both the stems are of equal length. The bulb on the transmitter is usually round, but at the negative terminal it gets flat. So that's how we come to know that it is a negative terminal. So the positive terminal has to be connected to the positive terminal. So, and then an on-off switch which controls the power to the entire circuit. And then a bridge rectifier. In case you are giving a power supply through a transformer, you need to convert that into a DC output. So for that we use a bridge rectifier. So it has 4 terminals, 2 AC input and 2 DC output terminals. The stem which is longer in length is the positive terminal of the DC. So while inserting, we have to ensure that the positive terminal is towards the bottom left side. The rest of the pins will align by itself. And then a capacitor. A 1000 microfarad capacitor is used to remove the repulsors which were present during the rectification process. So the stem which is longer in length is the positive terminal. In case both the stems are of equal length, there's a strip on the capacitor which indicates that is a negative terminal. So while inserting, we have to ensure that the positive terminal of the bridge rectifier is in line with the positive terminal of the capacitor. Then another 2-pin connector is used to give a parallel power supply to the motor driver IC circuit. And then a voltage regulator IC is used. So this is a voltage regulator IC 7805. So the stem on the left side is a input stem, and then common, and then the stem on the right side is the 5 volts output stem. So while inserting, we have to ensure that we are facing the input stem. We're facing the first stem like this. And then we insert 3 2-pin connectors here. And along with that, we insert 3 resistors of 10K with color code brown, black and orange. So, with color code brown, black and red. These are the resistors of 1K with color code brown, black and red, because these are LEDs. So we need to protect the LED. So for that, we use a resistor of 1K with color code brown, black and red. And the 3 connector bases will be connected here, and an LED which indicates the power here, the power indicator LED. Now the negative end of the LED will be on the right side, and along with that another resistor of 1K. So this completes the section of the power supply, and then we insert this IC base. So this is the IC base, and this is the 40-pin IC. So as you can see, there's a notch on the top side. There's a notch on the top side. So the pin which is on the top left side is the pin number 1, and then counting counterclockwise, pin on the top right side is the pin number 40. So before inserting the IC base, we insert this. Before inserting the IC, we insert a base in order to protect the IC during soldering process, or in case you need to replace the IC in the future. So while inserting the base, we'll ensure that the notch is on the top side, and on top of that we insert this IC. And this works on a clock frequency. So we use a 16 megahertz crystal oscillator, And this crystal oscillator gives a clock frequency to the microcontroller, and along with that we use two capacitors of 33 picofarad each in order to start the oscillation process. And a micro switch is used in order to reset the microcontroller, and this does not have any polarity, so you can fix it in any way. And then another resistor of 10K with color code brown, black and orange in order to pull up the microcontroller switch, the micro switch. And there are a number of potentiometers used. You can see there are 1, 2, 3 potentiometers used. One is to control the sensitivity of this LDR. The other one is to control the sensitivity of the IR transmitter and receivers, and the third one is to control display properties of the LCD screen. So we'll insert all the potentiometers. These are potentiometers of 10K. And then a decoder IC is used, 14 pin LM324 decoder IC. So as you can see, the notch is on the right side here. So first we'll insert the base. The notch will be on the right side, and on top of that we'll insert the IC, and then a network resistor is used. So this is a cluster of resistor of 10K each. So as you can see, there's a dot on the network resistor. So while inserting, we'll make sure that the dot is away from us. So this dot will be facing the microcontroller. And then another 3-pin connector base to give a power supply to the IC, motor driver IC, to give the input to the motor driver IC. And then we'll insert the LCD. So for that we'll use this base. So first we'll insert this base. This is a male birth strip, and first this is inserted, and then this is a female part which is mounted onto the LCD like this, and then soldered, and then it can be mounted onto the male part. So this completes the assembly of the main components on the main PCB. Then this is the PCB of the motor driver IC. So first we'll insert the power supply connector base, and then another 4-pin connector base, then voltage regulator IC 7812, and then the motor driver IC base. So the notch is on the top side, as you can see, and then 2 terminals, one on either side, one to control the motor, the other one is to control the bulb. And you can see a number of metallic wires used. These are called jumper wires. So when the connection is not possible from the bottom side, we use jumper wires to connect complete the circuit from the top side. And now once you finish connecting the components, we'll check the power supplies. For that we use a digital multimeter. This is a digital multimeter. The black terminal is connected to the body of the voltage regulator IC. And then first we'll check the power supply at the input, the first stem. As you can see, it is the input supply, that is 11 volts almost. And then the third pin should show 5 volts because it is a 5 volt power supply. 40th pin of the microcontroller should show 5 volts. Now this is the transmitter. This is the power supply to the transmitter. So the outer one is, as you can see, is the positive, and the inner one is the negative. the second pin and the second last pin of the LCD screen should show 5 volts. So for receiver section, for the receiver, as you can see, one is a positive supply which gets a continuous 5 volts. As you can see, this is continuously getting 5 volts, and if you check the other one, as you can see, the voltage is varying. So the terminal which is getting a positive terminal, the terminal which is getting positive power supply is connected to the negative part of the receiver, that is the cathode. I repeat, the terminal which is getting the continuous positive terminal, a positive supply, is connected to the negative part of the receiver, and the terminal which is varying in voltage is connected to the positive part of the receiver. Similarly, for the other receiver also, as you can see, this is continuously getting a positive power supply, and this is varying in voltage. So here also, the terminal which is continuously getting the positive power supply is connected to the negative terminal, and the other one is connected to the positive terminal. And then here, the outer one is connected to the LDR positive terminal, and the other one is connected to the negative terminal. So, and then we'll move on to the other one. Here you can see there are 3 terminals. One is getting a positive, this is depending on the output of the microcontroller. So we'll first then check the other circuit. So here you can see the input is the input power supply, and the output is almost 10 volts here, and the power supply here, the outer one is the positive terminal and the inner one is ground. And then the first terminal should show the input power supply, then the 7th should show the input, 8th, and then 14th. And so here 2 terminals are connected to the 2 terminals here on the first 2 from the bottom are connected to the first 2 from the right, because these are connected to the motor. As you can see, the 2 terminals are connected here, and this terminal is connected to the motor. The remaining 2 terminals, one of them has to be connected to this particular terminal. So this the top one from our side is connected to any one of the remaining terminal, and the other terminal is connected to the bulb. So this is how the connections are done. So once you finish these connections and check the power supply, then you can carry on and finish your kit by yourself. So you can order this kit by from our website kitsguru.com, where you'll get 2 versions of the kit. One is where you'll get the complete ready-made kit, and the other one is where you'll get self-assembly kit, where you'll get all the data sheets and other information to finish this kit by yourself.